Question 6, quite fiddly, but quite a few marks for not much work really. So we need to do circumcenter. So there's two circles you might have to draw. There's the orthocenter and the circumcenter. The orthocenter, you bisect angles and then join up where those bisections meet. And the circumcenter is where you bisect lines and you join up where those lines meet. So as is circumcenter, so we're going to bisect some lines. I've bisected X and Z here. So you have your compass set past halfway and you come across. Don't change the compass around now, put it on this side again, come across, join these 2 points up and you bisected the line. Do exactly the same for Z and Y. You can move your compass now, but set it again past where you think halfway is, go across, set it this side, go across, join them up. Where these two lines meet then, the perpendicular bisectors, where they meet, that's the centre of your circle. And then you just draw a circle around that point that meets the three corners. Now mine isn't great because between me and you I did it with a piece of string, so I haven't got a compass here, so it's not ideal. I don't think I'd get all the marks there, but hopefully it shows the method. If it was an orthocenter, you'd be bisecting an angle, and trying to join them up that way. Okay, so part B. Right, part B, you need to know two circle theorems. So one is if you've got a diameter and you draw a triangle off that diameter, the angle is always 90 degrees. And then the second one I like to call the bow tie is if you've got a bow tie shape where all four corners touch the edge, then these two are the same as each other at the angles, and these two will also be the same as each other. So these might be both 30 and these might be both 50, for example. Okay, so we look at this triangle. First thing I see straight away is a diameter, and I see a triangle going off that, so 90 degrees at the top of that angle. And then because down here it says ABD is isosceles, well, if that's 90 and there's 180 altogether, it means that the other two have to be 45. So I put 45 there, and I have to add 5 on because I'm looking at this big triangle here. So that's my first little bit of working out. And then the second thing I see is the bow tie, which is a little bit harder to see, I think. So if you go from A to B to D to C, I might even shade it in. So that is a bow tie, if you can see that. The shading is not great here because of the light. I think you can see it now. So basically this little bit at the top of A is the same as this little bit at the top of D. So if this is 5, so is that. Which makes this whole angle, which is actually the one that you're trying to find, 90 and 5, so 95. How to read these, I probably should have said this at the start. You're trying to find ADC, so you go from A to D to C, so it's the whole of that. If it was ADB, then it would just be the 90 bit. So hopefully that makes sense. So 95, and I've just written that up there because yeah. Right, part C. This is a proof, bit weird. I've not seen this exact question before, but we need to show that that basically this isn't a diameter and that the center isn't there. It's out here somewhere. So that's what we're kind of trying to prove. So we've put that there. And the reason is, down here it says, if you're proving this by contradiction, which is exam speak for, you probably should be proving this by contradiction. Your first line should be that assuming that it is. So I've written that first line, because they've basically told me to. And then I've drawn O inside the circle, which looks really wrong, but I suppose that's what this proof's going to be. So put the centre there and say, right, that's the centre of my circle. And now, if I join this up, I can see a rocket ship type shape. So it looks like a spaceship. Looks like this, basically. So if this is O, then this angle here is half of this angle here. Or this one's double this one, basically. So this fat one here is double the one at the top. So this is the rocket ship thing. Now, we've been told that angle R is greater than 90, and I'm coming to that because it's bold. so it's greater than 90. So this might be, I don't know, 100, right? Because that's greater than 90. It might be 95, whatever. Now, if that's 100, that makes this angle down here double that. It makes it 200, which clearly it isn't, because it's less than 180, because it's not a straight line. Okay, so this top side might be 200, but the bottom side can't be less than 180. And that's your contradiction. If this is bigger than 90, then this is bigger than 180, and it's not allowed to be. So it's as simple as that. If x is greater than 90, then 2x is greater than 180. This is not true. So O is outside the triangle, because it can't be inside. I probably should have put it can't be on the line either, because if it was, this would be 180 and that'd be 90, and it's going to be greater than 90, so that doesn't work. So yeah, that's your contradiction. Bit of a weird question. If it doesn't make sense watching that first time, watch it back. I'm sure it will.